So we've seen how to get a mean from a frequency table. We've seen how to get the mean just in general for given the list of data. In this video, we're going to want to look at how to get what's called a weighted mean. And for most of you watching, you're probably most familiar with this idea because it's used to calculate your final grade for a course, right? Not every grade you get is worth the same within a course, right? Classwork and tests and quizzes aren't always worth the same. And then also, your midterm is usually worth, at least in our school, and final, they're each worth 10%, and each term is worth 20%. So those numbers are weighted differently. So we want to build up to this idea of how to calculate a weighted mean. And what we're going to do is we're going to first just start with the idea that everything's weighted equally. So this says find the mean of the 4 test scores. And we're just going to assume these 4 tests are weighted equally. So to find your test average, so let that be your test average. Or your mean test score, I guess I should say. First, I'm going to do what's called the division way, which we're familiar with, so I can lead you into what I'll call the decimal way. And the decimal way will inform us on how to do weighted averages in general, or weighted means in general. So the division way, it just means add up your 4 numbers and divide by 4. Pretty straightforward. Now, I'm going to actually rewrite this in a way that's going to tell us how to do it the decimal way. So this can be written as 78 divided by 4 plus 96 divided by 4 plus 64 divided by 4 plus 100 divided by 4. And not only that, this can be written as 1/4 of 78 plus 1/4 of 96 plus 1/4 of 64 plus 1/4 of 100. Now, at this point, I don't care about simplifying this and getting the answer. This is where I wanted to get you to, because I want to point out that the decimal way of doing this problem looks like this. Looks like this. We should notice that 1/4 as a decimal is equal to 0.25. So really, if all 4 tests are worth the same, as I mentioned they are, that just means they're each worth 25%. So rather than do it by the division way, it's better to think of it in terms of this, or in this way. That 78 is worth 25%, so I just do 0.25 times 78. The 96 is worth 25%, so I do 2.25 times 96. The 64 is worth 25%. The 100 is worth 25%. This is the decimal way of thinking of averages. And again, this is because each test is equally weighted. Right, 25%. Okay, so this either way is going to give us the same answer, but if you punch this into the calculator, I bet you get 84.5, hopefully. Okay, so this is going to lead us into thinking about calculating weighted averages in general, because this technique of multiplying the weight as a decimal by the actual value will get us to the average more quickly. So now we're going to look at finding a weighted mean when your scores are not all weighted the same. So in this case, you've got somebody's, I guess it's Megan's grades for her junior year, and she's got term 1, 2, 3, 4, the midterm, and the final. No, they're not all weighted equally because the midterm and the final are weighted half of what each term is weighted. So let's let x bar equal Megan's final average, her grade for the year. And I'm going to really draw this out. I'm going to do it the long way, then I'm going to circle the way I want you to do it from now on. So what this means, when it says that 96 is worth 20%, what that means is that if you were to sort of think of all these scores as just individual data values, that means that the 96 would count 20 times. So imagine you have 100 data values. That means 20 of them are 96s, 20 of them are 82s, 10 of them are 91s, 20 of them are 95s, 20 are 80s, and 10 are 90s. In other words, you can do this problem by thinking of this as getting an average the division way by saying 96 plus 96 plus 96 and writing out 96 No, we're not going to do it, but you'd have to write it out 20 times. So I'm just going to indicate that's 20 96s. Let me write it in words so it's not confusing. There's 20 of those. Okay, but then we're going to add that to $20.82s. And we're going to add that to 10.91s. And we're going to add that to 20.95s. You can see I've run out of room, so let's see if we can adjust here. So now I've got, I got the 95s, now I've got 2080s. And then I've got 1090s. So I'm abbreviating because obviously we're not going to write them all out. There's 20 of those, and there's 20 of those. Sorry, there's 10 of those. Okay, and then we're imagining that there are only 100 scores, so we would divide by 100. Bear in mind, we're never going to do it this way. But again, 2096s is just the same thing as 20 times 96. So there's 20 times 96, and there's 2082s, and there's 1091s, and there's 2095s, and there's 2080s, and there's 1090s. And we divide by 100. So this is a little bit better of a way of thinking about it, but we can do even better than this, because 20 over 96, 20 times 96 plus 20 times 82, etc. This can be written like this: 20 times 96 over 100 plus 20 times 82 over 100 plus 10 times 91 over 100. So that can be written like that, and we're almost done. This can also be written as 20 over 100 times 96, and the next one can be written as 20 over 100 times 82, and this can be written as 10 over 100 times 91, 20 over 100 times 95. And this is the punchline, because like I said, We never want to do it this way. But the point is, it's still, this may seem like a waste of your time, or you may think it is, but it's not. Actually understanding that this is how you can always go back to thinking about averages from a weighted average, a table in which values aren't weighted the same, that actually in a strange way helps with other problems in which data is given us sort of an indirect way. But the point is that 20 out of 100 is just the same as this decimal 0.2, and 10 out of 100 is the same as 0.10. So we can, from now on, just think of getting the average by doing this calculation, right? So again, imagine we had to start over now. You just look at your table, and that 96 is worth 20%, so 20%, 0.2 times 96, the 82 is worth 20%. So I'm just multiplying the values by the decimal equivalent of what they're weighted. Now notice that the thing to point out is that there's no division in this way of thinking about averages. Right? So that we've kind of advanced our understanding. We've advanced our understanding of averages here to a better way that doesn't involve the fraction bar. Notice, like, no division is at all needed to calculate this weighted average. It's just the decimal version of what the value is weighted times the value. Because the division part comes from, if you just sort of look, retrace these steps in reverse, there is division going on if it comes from that decimal. But in the future, this is how you need to think about weighted averages from now on. And this, to evaluate it, you should get 88.7. Okay, so her final average is an 88.7. So going forward, you can find the average by just multiplying the decimal equivalent of the weight times the value and summing.